German gearboxes stopped American warships. Chinese warships used Chinese ones. This is the Gearbox War.
America chased peak performance. China chased mass production. Two factories, different philosophies. China picked simpler, heavier gears, built to never break under load.
In January 2021, the United States Navy refused to accept delivery of its newest warships. Several Freedom-class ships had suffered the same failure in their combining gear. The gear had to merge power from two gas turbines and two diesel engines into a single shaft. The design authority for that critical part was Rank AG of Germany, working through an American subsidiary. A joint Navy and industry team found a latent engineering defect in the high-speed clutch bearings. The bearings were under-engineered for the extreme loads that occur when switching between diesel and turbine power. The defect did not sink the program by itself, but it exposed a fragile industrial model. Lockheed Martin acted as the systems integrator and combat system designer, while Fincantieri Marinette Marine built the hull far from the ocean. The combining gear itself was produced by an international team that included Renk leadership and MAAG gear technology. When the clutch bearings wore out prematurely, the ships lost one propulsion train and had to return to port at reduced speed. Acceptance was paused for nearly 2 years while a redesign was developed and tested. The episode showed what happens when a highly complex propulsion architecture relies on a single highly specialized supplier. On the other side of the world, China was launching destroyers at a pace that surprised Western analysts. Much of that pace rests on two very different types of gearbox companies. The first is Chongqing Gearbox, which is a dedicated military supplier under China State Shipbuilding Corporation. It is the only enterprise inside the shipbuilding system officially designated to build main reduction gears for large surface warships. The second is Hangzhou Advance Gearbox Group, which was founded in 1960 and built its reputation on commercial marine propulsion. Hangzhou Advance obtained military standard certification in 2005 and now operates as a classic dual-use enterprise. This distinction matters because it explains the Chinese version of military-civilian fusion. Chongqing Gearbox builds almost exclusively for the Navy, with shock-resistant and low-noise requirements from the start. Hangzhou Advance builds for both markets, using shared casting, forging, and machining capability. The factory infrastructure can be similar, but the design criteria, testing protocols, and quality assurance are fundamentally different. Military gears require tighter tolerances, redundant lubrication, and traceability that commercial gears do not need. Conflating the two factories as identical, therefore, misses the real industrial picture. The Freedom class used a CODAG arrangement, which stands for Combined Diesel and Gas. CODAG promises great fuel economy at low speed and extreme speed when the gas turbines engage. The price is a combining gear that must handle two completely different power sources with a high-speed clutch that engages under load. That clutch is where the Freedom class failed because the transition created loads that the bearing design could not sustain. China uses different architectures for different ship types rather than pursuing one aggressive solution for all. Many smaller vessels use CODAD, which merges diesel with diesel, a far simpler and more forgiving arrangement. Larger Chinese destroyers use COGAG, which merges gas turbine with gas turbine. The Type 052D uses a CODAG arrangement where either diesel or gas drives the shaft, but never both at once. The Type 055 uses 4 QC280 gas turbines in a COGAG layout driving 2 shafts. All of these designs still require a reduction gear, but none require the same extreme clutch transition that doomed the American gear. The result is a heavier and less power-dense gearbox that is easier to manufacture at scale. It is a deliberate trade that prioritizes reliability and maintainability over peak performance. The QC280 gas turbine illustrates why the Chinese timeline is more complex than it appears. China acquired the underlying GT25000 technology from Ukraine through a transfer agreement signed in 1993. Early installations in the Type 052B and Type 052C suffered blade and reliability problems in the mid-2000s, and 2 ships sat for years without acceptance. The mature naval variant, now known as QC280, only reached stable mass production around the mid-2010s. After extensive domestic development, it now provides roughly 30 megawatts per unit, giving the Type 055 a combined output of over 130,000 horsepower. This history shows that China also went through a long debugging phase. It simply completed that phase on land before scaling. The reduction gears for these turbines are developed under organizations such as the 703 Research Institute, which focuses on marine propulsion research. Physical production is handled by state-owned defense manufacturers such as Chongqing Gearbox. With final integration under China State Shipbuilding Corporation, these gears are designed to meet military standard requirements for underwater explosion shock and low acoustic signature. Public data on noise and vibration performance is not available, so direct comparison to rank in those metrics cannot be verified. What can be verified is that China emphasizes land-based testing of the complete propulsion package before installation. The United States also tests on land, but the American program moved to shipboard production before the integration issue was fully understood. The real lesson is not that Chinese gearboxes are superior to German gearboxes. The lesson is that the two countries chose different industrial strategies that reflect different strengths. The United States built an exquisite, high-performance part with very few qualified suppliers. When that part failed, there was no rapid second source, and the entire class paid the price. China built an ecosystem where commercial capacity forging and precision grinding already existed at massive scale. That ecosystem can be mobilized for military production, though conversion still requires time for materials certification and workforce training. China does not commission a destroyer in months, as some headlines claim. A Type 055 still requires roughly 3 to 4 years from keel laying to commissioning, compared to 5 to 6 years for an Arleigh-Burke-class destroyer. The advantage is interval and throughput, with multiple yards launching in parallel rather than single ship speed. The American advantage remains peak engineering and acoustic performance, while the Chinese advantage is fleet-wide availability and cost control. Both approaches carry risk. One risks a single-point failure that grounds a fleet, the other risks long-term reliability and noise that may only appear after years of service. Understanding that trade is more useful than declaring a simple winner in the Gearbox War.